So here's some weird exponents. You learned when you learned exponents to begin with that 2 cubed, the little 3 means repeated multiplication. That's 2 times 2 times 2, and that's equal to 8. But now we're going to deal with some weird things. Like if you had repeated multiplication, and it's a 0, that doesn't make sense. Type it into your calculator. What does your calculator say the answer is? 1. What?
Anything to the exponent of 0.
And what is 3 to the minus 2? -9 would sort of, your brain would like that.
1 be 9?
Right? Unfortunately, your calculator tells you it's 0.1 repeated. What?
That's great.
And we're going to have to figure out these without our calculator.
Yeah, why?
Because we can.
No, I said like answer.
Oh, wait, why? This is the big question. Why? And the answer to the why mathematically, because sometimes teachers will just say, just memorize that anything to the power of 0 is 1. You should just know that. But if you have a reason why, it's a lot easier to remember. So, we know that 2 cubed is 2 times 2 times 2 is 8. And you know that 2 squared is 2 times 2, which is 4. And you know that 2 to the 1 is just 1, 2, 2. And you can figure out the next one going up, right? 2 times 2 times 2 times 2. You could do it that way, or you could just say it's going to be this one times by another 2, you would get 16. And for the most part, pattern-wise, you have always gone up. But there's no reason we can't go the other direction. What happens if I went down? What would be the next one I write on the left side? 2 to the 0. And what happens the pattern here? We're dividing by 2. We can keep the pattern going. What would be next?
0.
Well, what's the pattern on this side?
1/2. Oh,
And if you did it again?
1/4.
1/4, which very coolly, I don't know if that's a word, is 1/2 squared. And 2 to the minus 3, cut this in half again, you would get 1/8, which I'll misuse that word again, very coolly. Oops, is 2 to the 3. Does it work with other numbers? So if we did this, sure enough, it works. This pattern, can you see this pattern would work with any base? Like if I had, let's do it with 3. 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27. What's the pattern on the left? I'm going down by 1. What's the pattern on the right? We're dividing by 3. So it'll be 1 for 3 to the 0. And 3 to the minus 1 will be 1/3. And 3 to the minus 2 will be 1/9, which is the same as 1/3 squared. So we have 2 new rules that we can figure out as a result. We have our 0 exponent rule and our negative exponent rule. I don't know why in yours it put that little square. But 2 numbers whose product is 1 are called reciprocals. So, for example, what would you have to multiply 1/2 by in order to get 1? You'd have to multiply by 2/1. That would equal 1. What would you have to multiply 2/3 by to get 1? You'd have to multiply by 3/2. And you've heard this word reciprocal before, because when you divide fractions, the rule is when you're dividing fractions, you multiply by the reciprocal, or you flip the bottom fraction, right? And this idea of flipping our bottom fraction, here, let's do one more. What would the reciprocal of 5/7 be?
7/10.
Right? 7/5, and if you multiply them together, you get 1. That gets us to our negative exponent rule. A power with a negative exponent is equal to the reciprocal of the power with the exponent being, that word doesn't make sense to me. Any power with a negative exponent is equal to the reciprocal of the power with the positive exponent. That's a better explanation. So if I have 7 to the negative 3, I can write that as 1/7 to the 3. Anytime you have a negative exponent, you can change the exponent to positive by making it the reciprocal, or flipping it to the other side of the fraction. Check this out. What could I do to 8 to the minus 2? I could write it as 1/8 to the positive 2.
8 squared.
1/8 squared. Did you know that you could do the same thing if you have the negative on the bottom? What do you think 1/4 to the negative 2 is equal to? 4 squared. Which is much better than writing 1/4 to the negative 2. You want a crazier one? A little bit crazy? What could you do with 2 to the negative 2, 5 to the negative 3, 4 to the negative 5 over 6 to the negative 3, 7 to the negative 2? Well, you could write the 2 to the negative 2 as 2 squared on the bottom. The 5 to the negative 3 as 5 cubed on the bottom. And 4 to the negative 5 as 4 to the 5 on the bottom. The 6 to the negative 3 on the bottom can be 6 cubed on the top. And 7 squared on the top. So a negative exponent, usually what we do with a negative exponent is we change it to a positive exponent, because we're more used to working with those, and put it on the other side of the fraction. So if it's in your denominator, you move it to your numerator. If it's on the top already in your numerator, you move it to your denominator. Was that too quick? Are people still writing? Okay, sorry. And now we can mix negatives and fractions and everything together. So there's 6 here to try without your calculator. Write your final answer as a fraction. Actually evaluate, so then can you do 7 squared in your head? So then you'd write 1/49. Try these ones without your calculator. It'll be positive 2 there, and then you still need to evaluate it. So evaluate, here's an instruction word that people ask me on the test, and I say, I can't help you with that. Evaluate means get your answer as a single fraction where there's no operations to do in there. So this wouldn't be evaluating. This is good. This is good, but it doesn't help you evaluate. you still have something you need to do. What is 7 squared?
49.
So this is evaluated. There's your final answer as a single fraction in simplest form. Can you see that this one is the same as 10 to the negative 3 and 3 to the negative 3? Which would be the same as 3 to the positive 3 on top and 10 to the positive 3 on the bottom. And 3 times 3 times 3.
27.
And 10 times 10 times 10.
1,000.
And you've evaluated.
Jack,
Yes.
when do you think you'll get the test?
Well, a few people are writing them today and tomorrow, so hopefully by Wednesday, maybe tomorrow. Okay, part C, did you get
Hang on, I haven't
5 to
even
the
gone
4?
through it.
And 5 times 5 times 5 times 5? Ooh. I like this one because it's dealing with that negative. What are you going to do with the negative? There's options to do it, but you have to do something with that negative. How many people are unsure what to do with the negative? Everybody knows exactly what to do with the negative? Huh? So I could pick on anybody at this moment and they would be able to explain exactly what to do. Is there anybody unsure what to do with the negative? Oh, now there's that. Okay. Well, if you put it that way, Mr. Chair, you put me on the spot. Now, something you can do with the negative. You could say the negative went with the 3. Do you agree that that's the same? The whole fraction's done, the negative could be with the 3, or you could have said the negative's just with the 2. That means you have a negative 3 to the negative 4, and you have a 2 to the negative 4. Which then means on the top of my fraction I'd have 2 to the 4. On the bottom of my fraction I'd have negative 3 to the 4. And 2 to the 4 is 16. And 3 to the 4 is 81. And a negative 4 times is positive. What am I going to do with the negative here? I would probably do the 1/4 first, because it makes my life easier. 16 to the 1/4 is the 4th root of 16. Is there a number times by itself 4 times? That's 16? 2. So now this becomes 2 to the negative 5, which is 1 over. And can you do 36 to the 1/2 in your head? Or do you need to do this as a step?
6.
Yes. Alright, we'll leave the last question there for a warm up for next time.